Friendly reminder to everybody to please mute themselves if they are not the presenter so that we don't hear people puttering around in their
Good
kitchens.
evening, everybody. We're about to start. We are starting a recording. Mike, who is manager of Grid Innovation Calgary. ENMAX Grid Innovation team is preparing the electric system to meet the demands of an increasingly electrified world. So they're really focused on that. And by adopting new strategies and emerging technologies, ENMAX is transforming the way it plans, operates, and maintains a modern grid. Mike is an electrical engineer and has spent 10 years working in utility engineering design and construction before moving into ENMAX Grid Innovation team in 2021. He lives here in Calgary with his wife and their 3-year-old son. So with that, I'd like to hand it over to Mike and thank him very much for coming and talking to us. Please give him a very good welcome. Thank you.
Thank you for having me. Quick note, wife and yes, 3-year-old son, almost 3-year-old son. And also my wife is 37 weeks pregnant. So this phone is here face up. And if I make a mad dash for the exit, it's either because the questions have become too rigorous or something exciting is happening. So full disclosure there. But thank you very much for having me. I'm excited to come here and share a bit about our work and what's happening in the electricity industry, because I know it's of a lot of interest to everybody right now. And I'll start with this. So for anyone who grew up in Canada, anyone who grew up reading books to their kids, you might be familiar with this. This is the liner art from a children's book called The Hockey Sweater. And it's a book that takes place in 1946 in rural Quebec about a small boy who loves the Montreal Canadiens, as of course we all do. And he is devastated when one day a replacement jersey is mailed to him from the Eaton's catalog, and it is accidentally a Toronto Maple Leafs jersey, and his life effectively ends. And I mentioned it takes place in 1946. I read this to my son. He wants to, if anyone has a 3-year-old or has had a 3-year-old, you might be familiar with getting to read things over and over and over again. So I've read this book many times recently. And the reason I'm including it here is because what strikes me in this picture, in this type of art, appears throughout the book is, not the nuns walking through town. It's not the horses in the middle of town. It is the power lines running through town, which fundamentally look no different than the power lines we have today. And it's odd, the more I think about it, and I think about this kind of thing a lot, that at some point I will probably have to explain to my son that no, he should not expect to see nuns walking through his town. And no, it's unlikely for him to find a horse paddock outside of a hockey rink. And his referee in his hockey game will probably not be a priest. But the power lines I won't have to explain. Those have fundamentally been the same for 120 years. They're no different in the way they function, the principles behind them today than they were in 1946 or in 1891 for that matter. And that's really interesting, especially when you consider everything that's happening in the electric industry today. And the reason I'm here today to come talk to you folks about what it is that we're experiencing in the utility industry and what we're doing to prepare for this changing world. And when it comes down to it, I believe that this fundamental technology, this resource, this utility that we've enjoyed for 120 years is exactly what will continue to serve us. And that if we change the way we approach our planning and operations strategy, we'll be able to meet the demands of the energy transition and deliver a cost-effective, affordable, and reliable electricity service for many years to come. I jumped ahead too quickly. I'm supposed to now introduce myself. I'm Mike McCarthy, like Hugh said, and thank you very much for having me. I am an electrical engineer. I have always been in the electric utility industry, working with ENMAX here in Calgary for 13 years now. And what I'm going to talk to you today is a little bit of background on what those drivers are for the energy transition here in Calgary, specifically with an Alberta context, because the Alberta context is a little bit different than what Saskatchewan or British Columbia or Quebec or Ontario deal with. I'm also going to talk a little bit about our approach to innovation within the utility world at ENMAX and highlight some of the things that we've been doing already and continuing to do to understand the energy transition, understand what it means for the electric grid, and what it means for the future and where we need to go as an industry. So this is for those who haven't thought, actually, maybe a quick show of hands. I can't see the folks online, but anyone here who has worked in the electric utility industry specifically? Oh, perfect. I can make it all. Oh, wait, we got one. All right. If I lie, please keep it to yourself. We'll talk later. This is fundamentally how the electricity industry works. And this is something that is fairly unique to Alberta. There are a few jurisdictions in the United States, like Texas, that operate in a similar fashion. But across Canada, we are fairly unique, where we have a deregulated electricity market. And what that means is that there are different companies that move the electricity from those that generate and sell the electricity. So to those who are upset about their high utility bills that they pay to ENMAX, that's a different ENMAX. That's not me. And we can commiserate about it later because I also pay those bills. The way it's broken up is it basically between the meters. So between the meter at the generator all the way down to the meter at your home or at your business, that is the jurisdiction of companies like ENMAX Power. We are the distribution and transmission facilities owner here in Calgary. There are other distribution and transmission facilities owners across Alberta, like Fortis, ATCO, Altalink. And we are very separate from companies like ENMAX Energy and other generators and retailers who are responsible for either generating power or selling power to the end user. I'm also legally obligated to point out that anyone is free to buy their electricity from any of Alberta's excellent 45 plus retail companies. It's an open market. The fact that you live in Calgary doesn't mean you must use ENMAX. And if you're interested in finding more information about what's available, you can go to the Utilities Consumer Advocate at ucahelps.com. And they have a really helpful tool that helps parse through all the options that are available to you. And I swear I use it myself because there are a lot of different options out there for us. The way electricity has worked all the way back to, I think it's 1891, I said earlier. I believe that is 1891 when Tesla's first AC three-phase power grid was brought into operation, is we have centralized generation that sends power all the way down through it from transmission systems. So those are the big overhead lines that you might see when you're driving between Calgary and Edmonton along Highway 2. Those get stepped down through substations to the distribution system that either run underground in your communities or are the overhead lines that run through alleyways to your homes and businesses. And this has been pretty consistent in the approach. The types of technologies have changed. So the size of the conductors, the materials we use, the transformer technology has changed a little bit, but the fundamental principles of how this all operates has been the same for that almost or over 130 years. There's another point I had there. Oh yeah, this happens all the time. This is an important piece. This happens all the time continuously. So because it's all interconnected, because we're always going from centralized generation to decentralized load, there's always this balancing act that takes place where we need to make sure that the supply that's being pushed onto the grid is matching the demand that's being pulled off of the grid. That balancing act is the responsibility of the Alberta Electric System Operator, the ISO. There are many ISOs in every jurisdiction, or there are ISOs in every jurisdiction that are responsible for different elements of this. Jurisdictions are interconnected in different ways. So for instance, we can import or export energy to and from British Columbia or Saskatchewan or Manitoba. But that is a very tenuous balancing act to make sure that the real-time generation that's happening is instantaneously able to supply the active load that we have on the system and keep that in within standard operating limits, both on voltage, on frequency. So it's fairly complex, but a really simple way to think about it is it's a water system. You need to make sure the pressure on the system can meet the demand you have so you get the water pressure that you need. The way the electricity system works is fundamentally the exact same. And historically, what that's meant for ENMAX Power and distribution facilities and transmission facilities operators, that job has been pretty simple. Our mandate is to make sure that we have safe and reliable electricity for people. And that's written into the Electric Utilities Act. That is legislation that is governed by the Alberta Utilities Commission under the direction of the Alberta government. And that hasn't changed substantially in many, many years. what that means for us is that we need to make sure that as the system grows, as electric demand grows, that we grow the system to meet that demand. And historically, that's been pretty easy to do because we have very predictable behaviors. This is a literal load profile, the net Calgary load profile from a day in July in 2019. And this is no different than many other days where we see the demand for electricity peaking in the early evening hours, so between 5 and 6 generally. And that's peaking because of people running their stoves and running their dishwashers, and restaurants are running their businesses, and a lot of high demand activities are taking place. And that gently, gradually drops down until we meet our lowest demand in the early morning hours around 4 a.m. and then gradually again picks up until we hit 5 p.m. again. And that goes on day by day by day by day. And so as that grows, all we need to do is make sure that our system can handle this peak demand. We know that we can expect that highest demand around 5 p.m. And we know roughly what that demand is going to be. We have contingency factors built in. We make sure all aspects of the system can meet that demand. We have to do it safely. We have to do it cost effectively. And like I said, it's been pretty predictable and straightforward. But that has changed, and that is changing and continues to change. And the canary in the coal mine for this is California. Has anyone heard the term of the duck curve? Is that, yeah, I'm seeing some nods. So I'll explain it briefly in a moment for those who haven't heard it. But basically why this is changing is because as people adopt things like rooftop solar, and as people do things like electrify their transportation or electrify their HVAC system, so their home heating, their water heating, their air conditioning, that does two things to the system. One is that the high levels of rooftop solar and solar energy that's available means that the net demand in the middle of the day, so it's the net of what is being generated and what is being drawn from the grid, is at its absolute lowest when the sun is highest and those panels are generating at their max capacity. It also means that when the sun goes down, all of that generation disappears at roughly the same time. And because we're seeing higher levels of electrification, not only are we seeing a steep ramp rate from lowest demand to highest demand, but that highest demand is now higher than it's ever been and continuing to grow. This is generally brought up as a problem for, oh, the duck curve, I promised I'd explain that. Somebody pointed out it looks like a duck. That's it. Sorry. Yeah, a little bit like a duck. It's not a great duck. So this is generally, pardon? Well, it's, yeah, we're getting a little foul with the wordplay here. That deserves the groan. I appreciate it. This is generally discussed as a system balance problem or a generating problem, a supply problem, which would be a problem for someone like the Alberta Electric System Operator, because when all of that solar demand disappears at the same time, we suddenly need all this extra supply to be brought on the system pretty much all at once. And for places like California, places like Alberta, where there's a lot of thermal generation that is responsible for supplying electricity, that's challenging because those plants need time to ramp up. They need time to meet their max capacity. What this means for us as wires operators, and this is the part that's underreported and hasn't really been focused on as much when places like California have discussed the challenges of the duck curve, is that we now need to make sure our system capacity can meet this highest peak demand. And the challenge with that is that means upgrading systems, upgrading wires, upgrading transformers, upgrading substations, upgrading transmission lines, upgrading everything eventually to meet that highest peak demand for a peak that might only last for half an hour. It might only last an hour. It might last 2 hours. And the rest of the day, it's virtually not used, or literally not used. So it's not a very efficient or very effective approach to tackling this problem. It's literally, being a hammer and treating everything as a nail. It's not literally that, it's figuratively that, but I think you get the point. And so some smart people have pointed out, hey, this would be great if instead of having this big steep ramp rate problem, we could have those two phenomenon overlay with one another so that, hey, our high solar generation is meeting our peak demand. And that's generally referred to as flattening the curve. I know over the last 4 years, we've talked a lot about flattening curves, so people might not like to hear that. But effectively, all we mean by this is changing when and how people use electricity. And the solutions that we can use to make that happen are collectively referred to as non-wire solutions or non-wires alternatives. And what that means is basically anything we can do as an alternative to a traditional infrastructure upgrade to achieve the same outcome. So if you picture traffic as an example, the way we generally deal with traffic and traffic congestion is that we add more lanes to accommodate better traffic flow through an area. The problem with adding more lanes is over time, we have to maintain all those lanes. And that really those lanes are probably only being used during rush hour for that hour or 2 hours that they're being where the problem is present. And there are other things we can do to have that same outcome. Things like promoting active transportation, enhancing public transportation, changing what time of day people start work. All of those things would have the same outcome and come at a lower capital cost and maintenance cost to taxpayers over time. And so fundamentally, that same principle is what we're talking about when we talk about non-wire solutions and non-wires alternatives. Now, to do that, it's really easy to look at it on the graph and see, well, that makes sense. If we could make the lowest demand and the high solar generation time happen at the same time as the highest electricity demand, we would make better use of the assets that we have, mitigate the need for more infrastructure growth. But there's a lot of work that needs to happen to make that possible. Because like I said, this all happens instantaneously and it's constantly in balance, this balancing of supply and demand on the system. And that's typically done by someone like the Alberta Electric System Operator. So for a distribution utility to go and talk about ways of making that happen is really challenging, both technically, also from a legislative and regulatory angle. To make this conversation simple, I'm going to set that aside and just talk about what is technically possible and what it takes to get there, because the legislative and regulatory piece is a whole other challenge that is frankly bigger than we can get into in this conversation, and one that we certainly can't solve in the next hour. So just let's acknowledge that there are a whole lot of other things that need to take place before any of this transformation can take place, but that it is technically feasible and that there are ways that we can approach it in a cost-effective and affordable way for everybody. So the first aspect of it is to make all that, the outcomes, the benefits of non-wire solutions and non-wires alternatives make sense. We need to fundamentally change the way we plan the grid. And what that might mean is using some behind-the-meter assets instead of just relying on increasing someone's home supply, electricity supply. So if someone comes to us and says, hey, I'd like to bring in home EV charging, and so I need to upgrade my service. Something you could do as a utility is say, here's the cost of doing that, or here's a more affordable alternative where we use the vehicle to grid capabilities of your car to offset the load of your house during the day, and then you charge overnight when demand is lower, and you get the same outcome at the end of the day. There's things like, instead of upgrading some of your branch circuits or feeder circuits on the system, we could look at batteries as those become available. You can look at ways of changing our forecasting to account for all of these phenomena and looking at how weather impacts it and how climate change over time impacts it. All of those play into the idea of changing the way we plan the grid, and is a fundamental piece that a utility like ENMAX would need to be able to change before we be able to realize those full benefits. The other is looking at things like customer services. So demand side management programs is something you might have heard of. And these are often looked at in other jurisdictions as rebates that customers can qualify for. The simplest one that people might be familiar with is smart thermostat programs, where if you opt into these, subscribe to these, you would get something like a $5, some sort of fixed rate payment from your utility for participating. And they would toggle your AC or your home electric, home heat on and off in sequence with your neighbors, so that you're not all turning your air conditioners off at the same time, but still maintaining your house at the same level. And again, those work really well as opt-in programs. I want to really emphasize that piece, that the suggestion, the way these work well in other places, is that this is a carrot approach and not a stick approach. We want for these to work well, they need to be appealing solutions for people. There needs to be value in it for everybody. There are things like creating new rate options so people can have some choice and some more control over how, not only how they're paying their retail electricity rates, but looking at whether the distribution and transmission tariffs, those bulk fees that are included on your bill. I said that we weren't responsible for the bill, but that is what is paid to the distribution and transmission facilities operators in the province. So looking at different ways of staging those and giving people options in how they want to use electricity. And even things as simple as providing tools for customers so they can look and see, hey, what are the cost savings that I might be able to expect from energy efficiency solutions, from upgrading my fridge, from improving the insulation of my home, or third-party data access. So you can see, what does my actual consumption look like, and better understand the things that are within your control. All of those things are things that have never really been of interest to people, but as costs have risen, as utility rates are rising, as things like the carbon tax are coming in, people are paying more attention, and the data is available, or is becoming more available, so that we can be able eventually to provide this to people in a way that makes sense to them. It isn't just a huge upload of an Excel spreadsheet for people to figure out on their own. The last piece is kind of the biggest for us as utilities, and that is advancing the operations capability. So that is bringing on new technology platforms. The one we call it here is, I'll explain the acronyms because this was made for a very specific utility audience. So DERMS, so that's Distributed Energy Resource Management Systems. That allows us to do things like control the quality of power that's being exported from batteries to make sure that it's in phase with the system, or to make sure that reactive power that's being pushed onto the system or pulled from the system is keeping everything in balance for us. There are transfer tripping solutions to make sure that we can island sections of the grid if we need, where it's possible. There are things like energy management systems and advanced distribution management systems, which is a fancy way of saying automating a lot of these tasks that have historically been done manually by folks in a control center. One that you may have heard of is advanced metering infrastructure, so AMI. This is something that Calgary is in the middle of doing right now. So something like 50% of homes in Calgary have already been contacted and have had their meters upgraded to AMI, which is effectively, it's not a smart meter. That's not the appropriate term anymore, but it's an enhanced metering service that basically gives a higher resolution data of what's happening in your house. That meter isn't doing anything other than giving us better information about what's happening. So all those things are happening, or we've recognized are opportunities, and in some cases they're becoming requirements for utilities like ENMAX. And we recognize as a utility that a lot of things need to happen within our organization and how we work to make that possible and to make those feasible. So back in 2018, some folks at the company recognized, hey, the world is changing fast. We see vehicle electrification coming. We see high rates of solar coming. We know a carbon tax is coming. All of those drivers are going to push people to electrify over time. And we're seeing the trends already in places like California and Hawaii and Arizona, where that's happened a lot more quickly than it has here so far. We also recognize that ENMAX needs to adapt, and we need to learn how to integrate new tools and technology. That also means accepting a little bit of risk where we haven't before. Utilities have historically been a very, I used to say boring, but someone told me that was an inappropriate thing to include in a talk. So conservative industry where stable, thank you. That's a much nicer way to put it. When I used to tell people when I first started in engineering almost 15 years ago, or in utility engineering almost 15 years ago, people's eyes would kind of glaze over because it was an oil and gas town and there was a lot of exciting things happening in oil and gas, and utilities were just boring old utilities. And that, conservative, stable approach to utilities also occurs within the business, where we've taken a very risk-averse, safety-focused, reliability-focused approach to things, which means we're going to study and we're going to make sure that every single investment we make is going to be the most cost-effective for us and the most affordable for consumers. Now, that isn't changing at all, but what we've recognized needs to change is the approach to how we do that, and recognizing that we can probably do, especially as things change so quickly, we can probably learn more by trying things out on small scales in a lab setting or in a controlled setting in a way that we get more experiential learning. We can troubleshoot the problems up front and use those learnings to inform those strategic decisions instead of sending it to a consulting company to do a study for 2 or 3 years and then wait for the regulatory calendar to align. So we knew that this needed to happen in different ways. And I've got it in bold here, again, without impacting safety or reliability. That cannot change. So we need to find new ways of approaching these problems and trying out new solutions. We also need to figure out or recognize that the way we've structured our organizations will not necessarily continue to serve us. So as we've got new technologies coming out, recognizing that we don't necessarily have a team who's, tailor-made to handle customer vehicle electrification, because that's both a planning problem and an operations problem. It's also a customer services problem. And there's no one team that does all those things. And so instead of going first and saying, hey, let's change the org chart and then respond, using a team like the Grid Innovation team at ENMAX to fill that gap in the meantime. And once we know for sure how we want to tackle it, build from there. So our intent as a Grid Innovation team at ENMAX is to enable that change. We say sometimes we want to make change possible. Fundamentally, that means transforming the way we plan and operate the system, as I described, to optimize the capacity of the system. So that means, like I showed on that duck curve graph, making better use of our infrastructure overall so that we don't have these high peaks or systems built to accommodate high peaks and then that are greatly underutilized at all other times of the day. The approach to this is we've summarized it as think big, start small, and just start. And that's kind of a reminder for us to, hey, let's not wait to get things absolutely perfect as much as we might like to. Let's, because we can learn more by doing, and we can learn more even by failing in safe ways about how to proceed. And the approach to that is generally through things like pilot projects, where we can test assumptions, validate new technology as we go, and actually integrating those new tools as we go into our standard business practices. That's a pretty important piece, and one that I wouldn't have ever picked on when I came into an innovation team in a large company, because innovation, everyone kind of probably pictures something a little bit different when you hear innovation. You might picture people in a lab coat at a test bench. You might picture folks like Steve Jobs and Steve Wozniak doing some revolutionary design in a garage. It's really hard, especially in an industry where things have been the same for so long and people have been in careers for a long time. And they've moved through those careers because they do certain things well in a certain way. And so it's really important that we found to meet people where they're at. Having something really exciting and flashy off in the corner is neat and exciting. And it's also really hard to connect that to the day job and what the impact is on what we're doing and fundamentally why we're doing it, so that these things look more like core business and less like science fair experiments. And then following this practice of build, measure, learn, and repeat. So that comes back to that idea of pilot projects. If anyone's worked in innovation or worked in technology or read a book called The Lean Startup, this isn't new, this isn't revolutionary, but it was new for us and something that we had to really and continue to have to bring into the utility world. And we follow this idea, we call it the hub and spoke model. So the Grid Innovation team at ENMAX, we consider kind of the hub of innovation, which means we're both taking ideas in from the subject matter experts in the business and finding things at other jurisdictions and giving them out to the right areas and trying to be a central resource for folks without becoming a bottleneck, which is easier said than done. And something we continue to fine tune, but works pretty well and helps us avoid someone doing an innovative project over in a corner that someone else has already done. So we can try and share those learnings across the company. I mentioned that we do pilot projects. I try to steer away from that term because I don't know that we ever use it quite properly, because a lot of pilots look more like studies or demonstration projects sometimes. So the innovation project principles we follow, I'll follow these fundamental principles. When we're doing these things, it's to inform a specific decision. We're really trying to steer clear of just doing things for the sake of doing it. This might be neat. We should try it out. We want to make sure we have a really tangible benefit that we're trying to drive so that we can inform a strategic decision and fundamentally make sure that we are spending our money appropriately and spending customer money appropriately. We follow a minimum viable project approach. So again, for those who haven't worked in technology or an IT field, this might be a new concept, but the idea of just doing the bare minimum to launch a safe and reliable product that will give you the learnings you need. An example I like to talk about is a home appliance company, I think it might have been Cuisinart, has an anecdote that I heard on a podcast about their metal manufacturing plant going out of service and needing to pivot very quickly to a plastic manufacturing company. And they did a study, a quick internal analysis, and they said, well, it's going to take 3 or 4 years for us to do the assessment on whether this plastic will meet our needs and match the durability of metal. And one of their designers took the prototype plastic hand mixer, and they took a metal hand mixer that they were trying to replace, and he tied both of them to the back of his car, and he drove around the parking lot for 30 minutes and came back in and said, I think we're good to go. So we're not quite doing that with the electric system, but that fundamental approach, that principle is kind of what we're trying to latch onto to make sure that we're not wasting time on details that might not necessarily contribute to the outcomes we're trying to drive. And then always this build, measure, learn, and improve cycle. If we learn that something doesn't work out the way we wanted it to, we might stop and consider, hey, does this make more sense somewhere else in the business? Does this make more sense if we tried it in a different way? It's not necessarily, hey, let's do it and it failed and let's move on, but trying to make sure that any of the time and the energy and the money that we've invested in these projects is well spent and that we're getting everything that we can out of that. The way we approach this within the company is we try to make it as accessible as possible. So in the past, when this team first started, we took a very conservative utility approach to it, which was, if you have an innovative idea, give us a business case that details the cost, the resources needed, the timing, who are your sources, what other substantiating information do you have, how can you support this, and why is this a justifiable investment of our time and money? And unsurprisingly, we found very few people came to us and took the time to do that because they had day jobs to do. It was also really hard for us to take the time to properly triage those. And by the time we actually got to a point where it was approved, oftentimes the people who brought us those ideas had moved on either to a different company or elsewhere within the company. So recognize the need to make this easy and not expect too much of people, and really encourage this idea of ideation and innovation of the company. So we brought out this stage gate model that allows us to take a more streamlined approach to it. So the criteria for someone to bring us an idea now is anything from anyone at any stage of development. It can be as little as one word. Batteries, that's a literal one we got from a very high-ranking person at the company. And we've done things like that. And then within our team, we look at, okay, whether, and maybe it's a back and forth conversation to figure out, hey, is this a worthwhile use of our time? And is it worth pushing on to stage 2, where we would define what is it that we want to do with this? What is the intended outcome? What's keeping us from doing this now? And how might we test this out on a small scale to prove the benefits? And then it turns into more of a standard project where we develop it with people across the company, we execute it and collect data. And then finally, we take the data and the findings from the project and we make a decision on, what do we do now? Is this worth going to a business case? Do we revise standards? Do we bring in new tools and new skill sets? Do we start over again? We also try and take a very well-rounded approach to teams. So looking at a project less like an org chart and more like a circle. So looking at it where everyone within a project anyway has some say in what we do with it and how we apply it. I mentioned earlier that a lot of these new technologies can do many things. And so we want to make sure we're bringing all those perspectives in up front so that someone who comes at us with a very specific lens on what a battery, for example, can do, isn't putting blinders on and failing to recognize really good opportunities elsewhere in the business. A lot of people here have probably heard this quote at the top of the screen before, that if I asked people what they wanted, they probably would have said faster horses. This is commonly associated with innovation. I much prefer, when we're talking about innovation within utility context, this lower quote, which is, people don't want quarter-inch drills, they want quarter-inch holes. And this is the idea of taking a step back and looking at what's the actual problem we're trying to solve here, and not overly solutioning things, and not just trying to throw neat, perfectly good ideas out for us to tackle. We really try and take time to boil these down to what is the problem we're trying to solve and what is the best way to do it. And now into the more interesting stuff, which I think is the actual project work that we've been doing over the last 4 or 5 years within our team. Does anyone here drive an electric car? Is maybe a more interesting. 1, 2. Soon. I also don't drive an electric car. I should disclose that up front. I don't. But good. And have you, by chance, heard of our Charge Up program? Okay, perfect. We're all on the same page. So Charge Up started, this was one of the very first projects that our team did started in 2019. And it came from us recognizing that we don't know enough about electric vehicle consumption to know what the actual problem is. So we recognized that we needed to first get some understanding of what was going on. So we started a home charger program where we rebated people a certain, I don't even know what the amount was, but a nominal amount of money, a percentage of the total charger installation cost in exchange for 5 years of data from their home charger. And what this showed us very quickly was that people were very habitual in how they use their EVs. They plugged their vehicle in almost every day between 4 and 6. They unplugged it almost every day between 6 and 8 a.m. And during that time, was on average, the vehicles were plugged in for more than 12 hours. They only spent on average 2 hours charging. And I think the number is 40% of charging events lasted less than 30 minutes. We also saw that the average daily commute from people was 59 kilometers. There's some telematics that we're able to pull from vehicles through these pilot programs, and that the average daily charge session is 10 kilowatt hours. So for example, I was going to try and make an explanation of what 10 kilowatt hours equates to, but it's not worth it. It's not much energy. It's like having your dryer run for 2 hours is what it works. That's as close as I can get, I think. So this highlighted both problem and an opportunity for us. The problem being that because they're plugging in every day between 4 and 6, they are plugging in their cars at the time when grid demand is already highest. So they are contributing to that peak like we saw forecasted in California. The opportunity, though, is that that car then stays plugged in for the next 10 hours. And they don't need that electricity until they unplug the next morning. So there's a huge opportunity for us to encourage people to charge overnight, to shift when they're actually using that electricity. That would not change their expectation of having their car fully charged in the morning and would allow us to make better use of the systems that we have. So what we did during the next iteration of this project is we had 250 Calgarians. We invited anyone to sign up. We had 250 people sign up. We observed their charging behavior for 3 months collecting data from their cars. And we then segmented them into different groups. We kept one control group that we just continued to monitor for the rest of the year. We had one group that we called the education group, which was more of a nudge group, where we sent them some information that said, hey, did you know that it's more cost effective and more affordable and better for the grid if you charge between 10 p.m. and 6 a.m. The third group, we gave that same information, and then we added, and we will give you 3.5 cents per kilowatt hour for any charging that you do between 10 p.m. and 6 a.m. And this was the result on the left-hand side of the people in that nudge group who received no financial incentive to charge overnight. This profile looks almost identical to what the control group looked like, with very little change in behavior at all. We did see, and I'll show it on the next slide, a very, very modest uptick in the first month after we sent the, hey, do you know it's better? And then people quickly said, it's not worth it. But for the people who we gave 3.5 cents a kilowatt hour, this is the response that we saw. So we saw close to 80% of all charging was shifted to those hours when our grid demand or grid capacity is at its highest, shifted away from that peak time. This study was done and analyzed with partnership from the University of Calgary and University of Alberta. They helped us structure this and then helped us look at different ways we can also continue to treat the participants and treat the data to find more interesting insights. And so this is a graph that they prepared for us that shows the difference in charging behavior between those three groups I described. The really interesting one I want to point out is this line here that we did. This was an intervention we did back in September of last year, where the researchers pointed out that, hey, maybe this is habit forming. Maybe once people make the change, it'll stick. And so we contacted a certain number of people in the pilot and said, hey, just so you know, this reward is stopping. Thank you for participating. We're going to continue to collect data for the end of the year. And we were expecting that a certain percentage of those people would stick to the habit that they had established. Nope, they all regressed immediately back to the mean of everybody else. And this is pretty powerful because it shows us that it's really important for us to continue these types of incentives. And when we did some customer insights work after the fact, we found that people wanted skin in the game. They wanted to do it, but they didn't want to do it for nothing. They didn't want to do it at their goodness of their heart, which is fine and which is fair. even if it was easy and even if it was something that they could schedule in an app, the fact that there was something given in consideration for them shifting their behavior off peak was important to them. And that's important to us because it shows we can't just expect people to do the right thing. A really, sure.
Like generally, you have the ability to judge because that would be the same effect. Like if you, but I've never seen an option for a homeowner to say, okay, I'll take different rate at nighttime and daytime and then shift my habit.
So the question was, generally, are we able to do a time of rate, retail rate that would achieve effectively the same thing? And you're right, that's not something that's currently available in Alberta for residential homeowners.
We had it before. 20 years ago.
That may be.
Different rates.
That predates my time in Alberta, but so right now the way the legislation is written up is it's not actually something, and this is outside of the world of the distribution and transmission facilities owners. But the way most retailers work right now is those time of use rates are offered and are given to large commercial and industrial facilities, not available to most residential homeowners. I say most because ATCO, I know in their jurisdiction, ran a pilot where they adjusted their distribution and transmission tariff to basically add a corrective element that would compensate and basically be a proxy for a time of use rate. Right now, the infrastructure, and by infrastructure, I mean the advanced meters, the AMI meters I talked about, are not rolled out across Alberta. So it's not something that can be offered equally to everybody across the province. And so right now, most retailers do not offer that service. But because that infrastructure is rolling out, I expect that that's something you'll see retailers begin to offer. I'm not sure. I don't want to put a number on it because that would just be me speculating, but it is something that could achieve the same benefit. What I would point out, and this is Mike, human being speaking, and not Mike ENMAX, person speaking, is by moving to a time of use rate, it has, it's another hammer approach. And let's say we gave a time of use rate to everybody. And this is an approach that's happened in places like Nova Scotia and California and Ontario. That means everybody is paying higher power rates at the times they need it most and lower overnight. And only those who have the flexibility and really the privilege, the luxury of being able to shift those activities overnight are able to take advantage of that. And the people who don't have that luxury are small businesses, their families, and those people would effectively be paying more for that service they've come to expect. And so again, fundamentally, Mike, human being speaking, I would love to find more ways to have the carrot approaches and reward people for doing the things that are right, that can benefit everybody without necessarily going to a sweeping time of use rate. I don't think that opinion is necessarily widely shared. I think that we will see some version of a time of use rate eventually. It's been happening everywhere. And people seem to, like the idea. There's a feeling of control, I think, that people get from it. Is it worth it? Are people able to realize the benefits of that control? I'm not sure, but it's certainly something that feels inevitable. So hopefully there's some other options available for everybody by the time we get there.
I think that probably you have two elements to your electricity. One is your energy, and the other is your delivery charges. And potentially the energy piece is something that is a flow through. So if everybody had these kinds of AMI type meters, they're all residential customers. As somebody said, the commercial customers already have commercial, industrial. But if at some point ENMAX and other distributors were to roll out these AMI meters, at least the energy charge could be flowed through. And typically, the energy charges are much lower during certain time periods than they are during other times. And so if they could benefit from that. But what you're talking about redistributing the cost of the delivery system, yeah, that's another question. And even, that presently it happens with the the large customers, but certainly not.
Yeah, so the comment was, for those online, because I know that Mike doesn't pick it up, but the comment was, if AMI infrastructure was rolled out widely, some of these time of use rates from the wholesale market, where the wholesale energy changes hourly, the wholesale energy price changes hourly, might be available to everybody. And yes, that's true, that as AMI rolls out, that will become available. There are retailers already who have begun to suggest ways of doing this that I believe are available today to people, that you can find more info by going to that ucahelps.com. I'll also point out too that by opting into playing the energy market, you're exposed to the energy market as well. And so that's something that we want people to be very cognizant of when they sign up for things like that. So for example, yeah, at some point the electricity price may be below what your retail rate is. It can also go up to $1,000 a megawatt hour, which is $1 a kilowatt, which is roughly tenfold what people are used to paying. And that price is generally tied to demand and generally tied to when people need it most. So it's a bit of a double-edged sword. Again, people like the idea of having choice, and we're supportive of people having choice. We want to make sure though also that we're exploring all opportunities for the cost-effective delivery and making sure that people have the right information when they're making those choices. So I'm going to move on to more about EVs. I think there's a big opportunity. You know, one of the things I'm asked most often when people hear what I do for a job is really quickly, generally, can the grid even handle all these electric vehicles? And this is something that many of you have probably thought, or maybe a question that you've asked yourselves, maybe over a beer. Maybe you're preparing to meet me up front and ask me later. And the answer is the grid able to handle all electric vehicles charging at the same time? No more than the Shell station is able to handle every car going to fuel up at the same time. Mm-hmm. And so what I try to point people to is that when we have an electric vehicle, we need to think about charging differently than we think about fueling, and think about the opportunities of charging where you park your car anyway. So in the same way that we're pointing out, hey, people can charge their car overnight and charge it at a different time overnight without it changing their job to be done, their expectation of a charged battery. There are a lot of opportunities to take advantage of around things like workplace charging, where your car might be parked either at an LRT station, park and ride for 10 hours a day, or in your parkade downtown, or at the grocery store, places where cars are going to be there anyway. So there's a lot of data to support this. Stanford came out with a pretty compelling, very well established data-driven study back in January of this year that pointed to workplace and public charging as a great way to offset the load from residential areas where there's not as much capacity generally. Our commercial and industrial areas are built to handle very high load, and cars are there for long periods of time. And so if we could find ways to incentivize, and when I say we, I mean we as a society, because ENMAX Power is not in a position to go and start handing out money to people to install workplace charging. But if we could find ways to do that appropriately and in the right spots, we can make it a lot more convenient for everybody. So no more would we have to think about, I need to make a stop at the fueling station, but we could just have an expectation that wherever I might be parked, that I can be fueling while I'm there, and recognize that even if that doesn't get me to a full charge, I know that it's going to top me up a little bit, and that all those little charging events add up to help reduce that peak demand from contributing to from over contributing to that peak demand in the early evening hours. And this is really interesting when you apply that thought to fleets. I know Calgary Transit announced recently that they're electrifying their entire fleet, or a large swath of their fleet, by 2030. We've seen Amazon, we've seen places like UPS and FedEx and Purelator in the States talk about electrifying their fleets. And this is a really interesting problem for utilities, because they're not talking about, hey, one car charging for 40 minutes at a time around dinner time. You're talking about hundreds of vehicles charging generally at a depot in one concentrated area, which is a huge demand to meet and a huge challenge and cost for both that company and the utility. There are also a lot of opportunities for those folks, because those vehicles operate on a very predictable schedule, on very predictable routes generally. And I think there's a lot of opportunity, and this isn't something we're actively doing right now, but there are researchers who are looking at what is the right approach to how we handle fleet electrification and where are those opportunities. School buses is a neat one because those run between 7:30 and 9, and then they run between 3 and 4:30, and then they're either parked at a depot or parked at the school all day. Things like that really unlock, when you start to think that way of what's the job to be done of charging and where are those opportunities to do it conveniently without having to go out of our way, there are a lot of opportunities to help us meet that challenge.
So Mike, is there a
On to another
timer?
pilot project that ENMAX supported, and this is around solar adoption. So we called this our secondary network export project.
We're talking.
We were the first utility in Canada, and I think it was the second in North America behind only a utility in New York City to enable energy export onto our downtown secondary network. So I know were not many electrical engineers in the room. So the really quick explanation is that the way we design our electrical system in high density areas like downtown Calgary or downtown New York City is by paralleling a lot of sources into the same area, so that if one of those sources goes down, we can continue to be supplying energy to those buildings. That creates a lot of electrical protection challenges, where if you have something go down in an electric system, generally the approach is to open a breaker and cut power. And the way this system works is to specifically not shut down power. So the way that they've prevented power from accidentally backflowing into areas where it shouldn't, or pushing energy into a building and creating a power surge event, is by putting very strict protection parameters on their relays that says any amount of backflow means I shut this down instantaneously. That works really effectively as a protection mechanism. It also has the unwanted or unintended side effect of preventing those buildings from exporting energy onto the system. So if the Saddle Dome wanted to throw solar panels on their roof right now, they would be unable to export energy onto the grid because of those protection settings. And this is a huge limitation because a lot of those companies and a lot of homes and businesses in downtown Calgary extending into the Beltline are interested in installing solar, and that wasn't available to them. They weren't able to earn the credits of any export onto the grid. It was not technically feasible. And so our team came up with a unique solution by tweaking the protection settings to recognize a certain amount of solar energy to be pushed out without having those protection settings kick in. So moving it from a zero tolerance instantaneous protection event to a slight tolerance instantaneous protection event, we enabled export onto this high density network. So this was, I mentioned that high density network is generally downtown. We also have spot networks in places like Chinook Mall. And so our partner for this project was Cadillac Fairview, and that's where we have piloted it on a very small version of the system there. I mentioned wanting to try safe to try approaches and find ways to do this, to learn by doing. And so that's what we did by finding this spot network with a very willing customer who had full buy-in and full support to do this with us, and knowing that we could do it in a way that wouldn't impact other areas around us. We were able to test this out. So since April of last year, this has been operating. We've been successfully exporting onto the grid, and we're now in the process of tweaking these settings to make them available to anybody in downtown Calgary, so that when those homes and businesses decide, hey, it's time for me to put my solar panels on or my cogen unit on, that we have that solution ready for them. Another area that of big focus, and this was more of a hot button issue, or is
violation of, when you curtail somebody generating, electrical access, it is legislated, and so if you're able to curtail energy that somebody is producing in order to balance the system, that's sort of, I see what you're trying to do, but I mean, there may be areas where these things are being constrained as a result of lack of access to the system.
So the question was, is there any legislative problem preventing us from curtailing energy?
Yeah, in a sense, every generator in the province has to have access to the system, and every user has to have access to unfettered access. And so if you are restricting some generators I have solar at home.
Mhm.
If you tell me that you are curtailing some of it because the grid cannot accommodate that at a particular time, uh, that may be in violation of, unless it's a temporary thing, very temporary.
So I think perhaps we're misunderstanding the solution because this was not a curtailment project. This is not ENMAX saying you may not connect to the grid. It's that it was technically impossible to do it. And so if, let's say, a generator wanted to come and install in downtown Calgary 10 years ago, someone wanted to install a giant solar farm on the Stampede grounds, the response from ENMAX and any utility in the same position would have been, okay, here is the cost for you to tie in a line from your site to the nearest available compatible part of the system. And because of the secondary network configuration we had downtown, because that was infeasible, because it was technically impossible to do, that would have meant a pretty expensive run of distribution and transmission cable. And that's consistent with any approach. So it's not just limited to the network. If you wanted to install a solar panel at your home today and it required a service upgrade to your home, or if you wanted to increase the service panel size at your home, you'd be responsible for that cost up to the transformer outside your home. So it's the same fundamental approach.
Understanding. What I'm talking about is flowing the energy. You're producing, when I'm producing solar, I may not be subject to this, you're talking about the downtown area, but let's say there's a downtown person who's generating solar, and he's already connected and he's paid his, connection charges, everything. And if he's being curtailed as a result of congestion on the system.
There's no curtailment.
Okay.
Yeah, no,
I
what
thought
I've,
that's what you.
no, protection settings, not curtailment, but protection. So the
For voltage overruns or.
For overcurrent. So yeah, so the overcurrent protection, the same as a breaker in your home. The overcurrent protection for reverse power flow used to be instantaneous at any reverse power flow. And what we've done is relax that beyond the capacity of the system. So your system can export to the extent it's capable of. Anything beyond that would not be us curtailing export. We would have accommodated, that setting would accommodate your full export capability. Anything beyond that would constitute a protection event that needs to be protected against. So it would not be curtailment, it would be protection of the grid in the system.
If the net effect is, as a result of the requirement to protect the system, there will be some form of curtailment, right?
I mean, you would have bigger problems on your hand because it would be a result of a giant short circuit event on the facility. And so
that's all understood. What I'm saying is, it may not, you've got to set up the system in such a way. Now, for example, in the UK, they have energy services providers who actually help to balance the system. So they have batteries, they have demand response, they have, generators, and so they are now here we have the ASO balancing the system, and the distributors are distinct from the ASO, and so you have your own difficulties because there is no coordination between the ASO and the DFO, as you have mentioned earlier. And so these are some of the problems that we face here in Alberta.
And I think it goes above and beyond the conversation of that pilot project and what we're talking about. So I want to make sure that we're clear that this is not a curtailment project, and that the idea of hosting capacity, which is what you're talking about, and the ability for the grid to handle any export that someone would like to export, it is beyond the scope of what we're talking about in these pilot projects. And certainly that type of problem is something that utilities may expect to experience and are experiencing in places like California and Arizona and Hawaii, where there is very high levels of solar PV adoption. And those places have been quick to adopt. And we're building off and learning exactly from what those places are doing. So the policies and what we discussed here around the secondary network export project is not about curtailment, and it's not about restricting access, because you're right. Anyone has the right to export under Section 95 of the Electric Utilities Act to participate as a microgenerator. If they choose to participate in the wholesale market, they're also able to do that, and we are obligated to connect them and ensure that they bear their appropriate share of the costs on that. That's not within the scope of what we're talking about in this project. This project was about strictly enabling micro generators to export when they want to without compromising the safety and reliability of the grid. So if you want to chat more about that after, we can talk about that because you're touching on some pretty advanced stuff around flexibility markets and demand response. And you're right that places like Europe and the UK are much further along than we are in Alberta on that. And it's worth chatting about. But I'm going to move on right now to energy storage, which has been a really interesting topic for people for a long time. More of a hot button issue a few years ago when batteries were generally talked about, or seemed to be talked about, as the Swiss Army knife that could do anything and would save our souls and make solar energy available at any time of day. And so ENMAX is looking at a lot of opportunities for those within the system, looking at behind the meter options, looking at pole mount and pad mount options, so that, you know, in another world, and touching on the flexibility market you're talking about, you could address some of these load and hosting capacity problems by having batteries located on the system to help ride those out. Right now, batteries are generally being manufactured for places like California and Arizona, and we've learned very quickly that what California and Arizona consider outdoor rated is not outdoor rated for Alberta. We had one company who was very excited about their outdoor rated battery unit that was good to 6 degrees Celsius. For reference, our equipment is generally rated to -40. And so they were, you know, sheepishly forced to say, hey, yeah, no, we can't do that for you. We are doing some work, though, in Calgary. We are actually currently working on, and we have 5 behind the meter residential batteries installed at homes in an area where every single home has solar on the roof. That the developer decided we will have solar in this area, and that led to, like you described, some high levels of solar congestion on the grid, which basically means the next house that is going to install on the grid is going to force ENMAX to go and make a system upgrade on those upstream cables. We were interested in looking at, hey, if we schedule a battery to basically act as a mechanism to shift that solar export load to another time of day, how much can we actually defer the cost, or how much extra capacity can we add to the system? We're in the middle of collecting data on this, and this pilot's wrapping up at the end of this year, and we've been executing it with support from SREA, which is the Smart, Sustainable, Resilient Infrastructure Association based here in Alberta. And it's really led to some interesting conversations with the City of Calgary Codes Department, the Fire Department, and lots of people who are interested in knowing, hey, what do batteries mean for our day-to-day life? And really is a good example of, you know, taking this safe to try approach on a small scale first, and being able to learn with a few small people in one concentrated area before we go to a broader audience across the province. People have also, there are some jurisdictions looking at mobile batteries solutions. So this used to be discussed as the idea of putting a battery in a sea can on the back of a truck and driving it to a part of the system where you might need capacity at a certain time of day. Now, as we have more heavy duty and medium duty vehicles with built-in batteries, and electric vehicles that have their own batteries, and systems and technology that are vehicle to grid capable, there's a lot of research being done into how we can make use of plugging those into different areas of the system. I mentioned that concept earlier of plugging your car in when you go to the grocery store. You know, that applies for you as a charger as equally as it does to the grocery store. And maybe there are times of day when the grocery store wants to say, hey, we have a time of use rate I'd like to avoid, and I'm going to give you 4, I don't know, packs of mandarin oranges if you want to plug in your car at this time of day. It really opens up, again, a way of us rethinking how we treat electricity and what it means to different people, both on the consumer side and on the the small business side and on the utility side. That's all I have to say. That's all the pilot projects I'm going to talk about specifically, but I wanted to end with kind of just wrapping up and looking at how these all interconnect. And we took the time as the grid innovation team to plot out where all of our initiatives that we're currently working on, where they fall in the spectrum of advanced system operations, advanced system planning, and customer programs. And what we found is that most of them are heavily concentrated right smack dab in the middle of it all. And I think that really highlights not only the complexity of what we're dealing with and trying to understand, hey, where are these opportunities and how are we going to make this possible, but just how much opportunity there is there. And that when someone comes to us with a planning problem, if we have a robust operating system and a robust customer services portfolio, we probably have the tools at our disposal to solve that planning problem with the system we already have. And that by working together and recognizing that none of these things happen in isolation, by being agile, by ultimately by embracing change as an organization, we're going to be able to help ride out the energy transition and beyond ride out the energy transition, but make it achievable, attainable for everybody here, and as cost effective and affordable, most importantly, as possible. I said at the very start that I believe that that's possible, and I really do. I think that Calgary's in a pretty good position. We have some of the sunniest climates in all of North America, smoke notwithstanding. We have an entrepreneurial spirit here. We've seen, that sounds so terrible and corny, but it's true. There's a huge willingness to go and pull ourselves up by our bootstraps and try new things and build new industries and adapt and change. And you're seeing that already in Calgary as more tech companies roll in and as oil and gas companies look at diversifying their portfolios. And I think that combined, all those things really set us up for success, and that the work that we're doing within our team and at ENMAX is going to help set us up to succeed through that. So with that, I'd like to thank you for having me here and look forward to fielding some questions now.
So one thing I noticed you didn't speak to, as I understand, all of the modern chargers have the approach of internet protocol for monitoring and controlling their charging output by monitoring and linking to building management systems as one level, but they also have the ability to link to utility level versions of that control. Have you considered implementing that on a geo-fenced area so that you could sort of reduce the individual impact of charging on a specific transformer area, say?
Yes. So the question was, with new IT protocols and with the data that's available from a lot of this technology, it's feasible for us to link the geolocation of devices and equipment to areas of our system and to incentivize according to the system itself. Is that fair? Okay, I'm seeing a nod. Excellent. And that plays into the question again of the flexibility market, because it's a really good observation that the constraints or the challenges in one area of the system are not necessarily the constraints and challenges of another part of the system. Downtown Calgary's peak load is going to be at a different time of day than residential Calgary. A restaurant is going to be at a different from a school. And so recognizing those opportunities is what creates the possibility of something called a flexibility market. Portland, Oregon operates a flexibility market, which basically does exactly what you're describing and says, hey, you're in this area and charging is going to be more affordable for you right now. Or we're incentivizing you to shed load right now if you're able to turn off your appliances. Or if you've opted in, we'll do it for you through your smart devices. I mentioned the charging program we did, the second version where we incentivize people to charge at different times of day. That program was capable of doing that type of incentive. We chose to steer clear of it for that first iteration because of that minimum viable project approach. We didn't want to confuse the data by looking at too many things at once. We wanted to first establish, hey, is it feasible for us to convince people to change what time of day they're moving, they're charging at. And so we're in the middle of planning out a next iteration of this program and what it could look like that we're hoping will include elements of that. And like I mentioned, I was going to avoid the regulatory and legislative piece. It's tricky to do that and make it fair and accessible to everybody. So that's a huge consideration for us. And then the other piece, I've deliberately avoided this as well, but IT security, data privacy, those types of issues and how they relate to the competitive retail space and the role we play as the wires owner, like the distribution utility, gets really complicated really fast. So there are a lot of challenges to that, but it is a huge opportunity that's working in many jurisdictions. Portland is the most notable one that jumps to mind right now.
If there's no questions from the floor, I'd like to just read one from online. I think you partially covered this, Mike, but it's fairly lengthy. It says, what are the roadblocks to getting electric car owners to be able to power their house or push to the grid from their cars during peak hours and recharge during non-peak hours? Is that a path you're exploring right now? So maybe that's the first half of the question. And then it was more generally, for those without electric cars, what would the roadblocks be to incentivizing something like a power wall that ENMAX could tap into during peak and charge during non-peak? In your opinion, what's the lowest hanging fruit available that would have the highest impact on reducing wire-based transmission?
Okay, I'm going to start with the first one because that's easier. So the biggest barrier to vehicle to grid, using vehicle to grid to use your car to export to the grid or to export to your home, right now is the technology. So many vehicles are beginning to offer battery export vehicle to grid capabilities. For a long time, they didn't, frankly, because they weren't around long enough to know what the impact on battery degradation and warranties was going to be for them as manufacturers. We have enough data now on these big lithium-ion batteries to say, for manufacturers to say that they're comfortable in some cases with allowing that export. So technically, the cars are capable. There are now an increasing number of chargers that are capable of exporting onto the grid. And as a non-wire solution, it's a huge opportunity, especially when you think of your car's ability, even just to supply your home. Because I pointed out, most cars are driving only 59 kilometers a day, only need to charge up 10 kilowatt hours. Those cars generally, I think the standard Tesla battery size is 77 kilowatt hours. So there's a huge amount of capacity in that car that's able to supply the house and then still fully charge overnight. The biggest barrier right now is the technology, because as a homeowner in Alberta, under the Microgen Act, you could do that. You could register as a microgenerator, which requires going to enmax.com if you live in Calgary, or going to your distribution utility, or speaking with an electrician to point you in the right direction, in whatever jurisdiction you're in, to go and apply to be a microgenerator. You get classified as a microgenerator. It would say either you have a solar panel, or you have a battery, or you have a car. I don't believe we have any people registered as vehicle to grid microgens in Calgary right now. I'm going to go look now, but so technically, it's, from our standpoint, we're agnostic to it. It would be no different than hooking up a generator, which you technically could do, and pumping electricity onto the grid. Now, the second part of that question was, how do you enable it?
Well, what's from the lowest hanging fruit available that would have the highest impact on reducing wire-based transmission?
Lowest hanging fruit available. I'm a big fan, and they said in my personal opinion. So perfect. Yeah, because I don't think ENMAX would endorse this. I don't think we've decided what our stance is on it. Not that they wouldn't endorse it. I don't think it's very contentious. But I mentioned the ability of workplace and public charging, and that frankly is the biggest impact, because when we talk about residential charging, we're talking about the outer extremes of our system generally. For people who live, let's say you live in Northwest Calgary in Tuscany, the system ends out there. There's no further support. And so we're looking at, and really this applies to any residential neighborhood, you're in the lowest end branch of the system that's supplying to your house. And so those elements of the system are least capable of handling extra load. And when I say least capable, I mean they're least capable of handling every house in the street charging at once. So as more people adopt, and as more people decide, I want a level 2 charger at home, that increases the service sizes, which cascades over time up the system, or has the risk of cascading over time up the system and becoming expensive for us to grow and maintain, the same way as those extra lanes of traffic become expensive to grow and maintain. If we can prove to people that there is a reliable public charging network, a reliable workplace charging network that they know they can rely on, they know where it's going to be, they know it meets their schedules, they will see less of a need for that. Places like California are doing a good job of this right now. I say good job right now because they're correcting from the old way, which was, we're going to enable residential charging. San Diego Gas and Electric did a lot to allow people and enable people to install residential charging, and they're having a lot of problems right now. they're now trying to readjust, pivot to this focus on public. DC fast charging in some places, which they're installing generally at grocery stores and shopping centers, or workplace charging in places where the grid is already able to handle it, where you can optimize that capacity without adding capacity to your outer reaches of the system. So it takes a big policy push and a big systemic push to make that happen. But that is frankly low-hanging fruit because it doesn't involve new technology and it doesn't involve systemic change within any existing systems. It's just the decision to do it.
Excellent. Thank you. Any other?
Hi, Mike. I'm trying to call from my home.
Could you comment on the
Can
fact
you hear
that
me?
you made the analogy of putting more asphalt on the road to prevent congestion on the road for those couple of hours that have traffic jams? That's not the solution for the electrical system. I hear get your focus is really on smart grids, measuring, sharing, and everything in between. But what about what you read in the papers, what you get from other offshore references? Oh, if we need to do this before a certain period of time, let's not go into that political discussion. But we need lots more electricians. We need many, many miles of cabling. So it is not that's the wire technology. What's the split?
What's the split on how much more electricity? So the comment is, if we're going to use the smart grid to meet a lot of the challenge of increased electrification, are we still going to need all this cable, extra wires, and transmission and distribution growth like we're hearing in the media, or is there a balance of it? Is that a fair summary? Okay. I think you're right that there will be some need for growth over time. There has always been growth in electric demand, and especially as you look at base load shifting to electric, we're going to need to grow more. And when I say base load, I'm looking at things like home heat, water heating, those types of things that, especially during the wintertime, and as heat temperatures rise in the summer, more people are installing air conditioning, increasingly also in the summertime, the demand is high and it's consistently high throughout the day. We're going to need to organically grow to meet that. And even if, there will be tipping points all over the system at certain points where, hey, there's a lot of cars here, there's a lot of electric demand, we're going to need to grow this system. The challenge for us is to make sure we're doing that responsibly and we're doing that in a way that isn't reactively. Right now, the only solution we have is to grow the system, to build more wires, to grow the transformer capacity. And we don't want to be in a position of knee-jerk reaction and having to do that everywhere all at once. By balancing out and by bringing in some of these non-wire solutions, things like the demand-side solutions, which I would add as another low-hanging fruit piece, demand-side solutions that incentivize people just to change their behavior in ways that are easy and beneficial for them, that's going to help ride that out so that instead of hockey stick growth with exponential upgrades required, we can responsibly and proactively build out the system so that we don't end up with something that's overbuilt for that 40 minutes to an hour or two a day. So what that mix is, I don't think anybody knows. This is a weird field because there are no experts right now. I was at a conference in Toronto last year with Electric Mobility Canada, where someone was discussing multi-unit residential buildings, and they found someone from BC Hydro and said, I have to talk to you about how we install charging in our downtown condos. We have all these concrete condos that are built in the 80s. It's really hard to get new electric infrastructure in there. They're not built for, to add more equipment to the rooms. How do we make that happen? And the person from BC Hydro was kind of like, I don't really know. We're figuring it out. We're learning from those guys and they're doing it different from these guys. And everyone's trying to figure it out slowly. And, we're trying not to be that bleeding edge. And fortunately, we're not in a position where we have to be bleeding edge. We're able to, pick and choose who we learn from and how we apply it here in Calgary and recognize what solution works. But the fact that there's no one size fits all answer, and the fact that it is going to be gray and that there are lots of solutions, makes it hard to answer that latter part of your question of what is that right mix. And I think the goal needs to be responsible, deferring growth as much as possible, and recognizing that, some growth will be necessary, and try and make sure that we're doing that as responsibly as possible.
Can you please comment on the amount of copper and lithium required for your future projects?
I cannot, because I don't know what the future projects look like. I know, yeah.
And all the lithium projects are responsibly done at the moment, or there are some issues there?
Are lithium projects responsibly done at the moment? Frankly, that's out of my expertise, and I.
Driving an electric vehicle, but they want to drive an electric vehicle. I suppose the batteries are on lithium batteries, right?
I believe most of the batteries are lithium right now. I know there's a lot of work happening in Asia around sodium-ion batteries, where they're able to pull sodium from seawater, and also projects where they're looking at converting seawater to lithium to reduce the impacts of mining. And I think that's kind of what you're getting at, is the environmental impact of mining lithium. Yeah, and that's frankly outside of my purview, and I'm frankly agnostic to what people are how they're choosing to drive. I know that when people are choosing to drive, my mandate is to make sure that we're growing the system responsibly, and that anyone's decision to drive an electric vehicle isn't going to adversely affect all ratepayers in Calgary. Because I don't have a mandate that, and none of us do, that says I can forbid someone from driving an electric vehicle. So if people, choose to avoid lithium products or avoid batteries for reasons like because they're concerned about the environmental impact, that's perfectly rational. I can understand that approach. I can understand that reasoning, but it falls way outside of my scope of wanting to make sure that the grid's growing responsibly.
Well, you said worry, but if everybody was told that to get rid of it, something that would really impact the city of Calgary.
So the question was, if everyone was told to get rid of gas heating and switch to electric, would that impact the city of Calgary? The very short answer is yes. Am I worried about that? I don't think that's realistically going to happen. And when I say realistically going to happen, I don't mean soon. I mean, I don't think it's going to happen. It just seems like, and this is, again, Mike, person, human being, not Mike ENMAX, speculating, because no one knows. But I don't expect any politician in my lifetime is going to come. I shouldn't say that, because who knows? No time soon will that happen. Right now, the electric technology isn't there to meet the demands. I think there's a lot of opportunity with fuel switching, with using something like a heat pump or an air conditioner when it makes sense, and relying on a gas furnace when it doesn't. And I think that same rationale applies to electric vehicles, that an EV isn't necessarily the one-size-fits-all solution. My father-in-law loves to fly fish, and he is always on me about, hey, I don't think an EV is going to get me to and from fishing down at Lost Creek at Pincher Creek. Like, no, probably not. You should probably consider not having an electric vehicle, because I don't think it's for you. And long-haul trucking is starting to look at things like hydrogen solutions. People are recognizing that, EVs are a good solution for commuter vehicles, and they're a good solution to many of the transportation modes that we use right now. But they're not going to be able to do everything, and they certainly won't be able to do it right now. And heating is a whole generation or two behind that conversation. So, yeah, the short answer, again, yes. And I don't think we're anywhere near that.
Mike, thank you very much. I think if there's any further questions, maybe you can catch Mike after. It's just 8:30, so would like to wrap up the formal session of this meeting. And on behalf of the Canadian Prairies Group of Chartered Engineers, we donate to Operation Eyesight. It's an international development organization working to prevent blindness and restore sight. So instead of giving you a gift, we're going to give you this certificate to let you know that we have made a donation on your behalf. So thank you very much.
Thanks so much. I appreciate it. Thank you.
There's pilot plants in just by Oaks.